Hi everyone. Here we'll be solving yet another question of binary search. This is a medium level problem, and again, this is you can consider somewhat a typical problem. And here it is a type 1 problem itself, not a type 2 problem. It will also be type 1 problem, and let's see what it says. So you were given this array, this vector, you can say 2 2 3 4. So what you have to do, you have to find triplets. You have to find number of triplets that can form valid triangle. Okay, that can form valid triangle. And now, even before going forward, what is a valid triangle? What is a valid triangle? Like I think, I hope you know all these concepts from elementary school. So let's say you are given three sides A, B, C. So the smaller two from ABC, the smaller two from ABC, let's say A and B are they, like C is the largest one. C is the largest one. So ignore this C right now. So smaller of these two, oh sorry, smaller two of these three sides, which is A and B. So if you sum them, A plus B. Now, first of all, what is the condition here? Why are we taking A, B? Because A comma B, they are lesser than C. Okay, they are lesser than, or you can also say lesser than, equal to, no problem. But in that case also, these will be the two smallest one. So you want what? Two smallest sides. Okay, out of these three. So A and B should be lesser than equals to C, and at the same time A plus B, what the condition says to form a triangle, A plus B should be greater than C. This is the condition. So you choose A and B. How? Because they were the smaller two. And what condition says, like how, when this will form a valid triangle, these triplets will form a valid triangle when the smaller two of three, their sum, if you sum them, it should be greater than C. It should be greater than C. Keep this in mind, guys. This is the key for us to find our answer. Okay, now let's see what you can do. In brute force, you can obviously go for three loop approach, order of n cube, which is for inside that, a for inside that one more for loop. You can say I variable, j variable, k variable. Okay, and try to get three triplets like this, with I, with j, and with k, and then try to finalize how many of this you can get, like 3 a b c. Calculate and I, j, k. Try to find the smaller two and then apply this condition if that smaller two sum is greater than uh, c or not, the third. So this is the first approach. But here, guys, if you remember, this is somewhat we can say like a trivial or brute force. Here, if you see, the thing with us is, and the hint that we got, it was that the smaller two, we are interested, like, because forget about all the indexes, forget about all the scenarios, all the like permutations and combinations, what we'll be checking for ABC. What we know is for sure, first of all, A and B should be lesser than C. Let's say C is a larger one, A and B should be at least less than equals to, if not lesser than, at least what I'm saying is A and B should be lesser than equals to C. Like for these A, B only who are lesser than C, we'll search for A plus B. We'll look for A plus B, and if there is some C, some value who is lesser than A plus B, then we will go for the answer. So what you get again, guys, I'll be repeating what you get from this from the previous thing that we did is, for only those values, let's say the two values, the two pairs that I'm going to catch, and for them I'll be looking for the triplets. This a and b will be like, who will be they? Obviously they'll be smaller values than the C, because C should be greater. So don't you think, if I short the entire array, let's say this was already shorted, but let's say 4 2 3 4, I short this 2 3 4 4. Now, because when, let's say you choose any two doublet, sorry, you choose any two pair, you take 2 and 3, you take 2 and 3. Okay, you take 2 and 3. The other side, what you have to do, just think in a way that other side should be the right of it. Other side, because these are two heights, sorry, these are two sides, so other side should be the right of this side, in the right. Okay, in this way, you know that you do not have to search, you only have to search in right direction for the third side, for the C side, because C should be greater than A and B. So all these values are greater than A and B, and so with this idea, the first thing is we will short this array. I hope this thing is clear. Why are we shorting? Because the only C that is greater than A and B, sorry, the only C that is greater than A and B, we are interested in that. So I think you got this first thing. Now let's try to solve one test case and you'll get what this question asks. Now see guys, as this array is already sorted, we don't need to sort this, but think in this way that yeah, 4 and 2, let's take these two pairs, 4 and 20, not 4 and 2, 4 and 20. So if you see 4 and 20, all the c who are greater than this 20, like these two variables, we are interested in them. So our zone, our interest zone is what? This one. So here we have to find out our c. Forget about this right now. Now what is 4 plus 20, which is 24? Now see guys, 4 and 20, 4 and 20, they, if they are two sides of triangle, what can be the third possible side? Third possible side, first of all, it should be greater than 4 and 20, and at same time its value should be lesser than this sum. So it can be 21, 22, 23. Okay, these three values can be at this position, at this question mark. So see this, after 20, who are lesser than 24? 21, 22, 23. So this index, if you get this fifth index which is actually 24, so 5 minus what? 5 minus, sorry, no, this 24, because 23 one you wanted, right? Sorry for this, pardon me. So 23 is actually the last value which can be candidate for this answer, because it is lesser than 20 plus 4, sorry, which is 24. So 4 minus 1 index, 4 minus 1, which is 3. So with 4 and 20, how many triangles can be formed using like all these area set? With 4 and 20 as two sides, how many triangles can be formed? Three triangles. Okay, three triangles you can form. Of what length? 420, keep them as it is. Here 21, 22, 23. So if you see this carefully guys, our steps, what are they? First, sort the given array, and then for two values, anyhow you have to go for order of n square solution, because first for loop, second for loop, this I, this j, you have to anyhow go for this, you cannot like escape this. But the third space, which was for like j, you wanted for j, I'll say we were going linearly, and the array space was sorted, so don't go linearly, do here binary search thing. So in this way, I and j will be n square. The solution will be of log n time, because binary search is log n complexity. So initially your solution was order of n cube. Now your solution will come down to what is log n square log n. Okay, which is lesser, which is quite less than n cube. So we are this time our optimal solution is like better solution is this. Optimal can be like much better than this, but as we are solving only binary search, so we'll be sticking up to this only. Now see guys, so if you remember, if you see this, so the first thing is you have to sort this array, sorting. The second thing is, what is the second thing? After this j index, like you get for I and j, obviously you will keep your j in front of I always, in front of I always. So let's say you kept I here, you kept j here. So from j plus 1 to last, let's say h, your search space is this much, and what you want to find, let's say the target k, let's keep k, let's write k here, 20 plus 4, which is 24. Okay, so you want to find the final index, which is lesser than this 24, and which is this, here it is 4. So 4 minus, you did 1. Okay, so here guys, if you see, the question comes down to what? The largest value, find the index of largest value lesser than k. What is k? It is a plus b actually. And what are we doing? Why are we doing this? To find c. Now don't you think, like as I said already, given this hint that we'll go for binary search, but we have already done this sort of question, like largest value greater than k, sorry, lesser than k. So because this is array space is sorted, so let's say let's see this, that 21, as going with the previous example, let's see this, and 27 itself, like let's keep here as well. So what is your interest is, like, what are you interested in? Lesser than k you are interested in. Okay, 0 1 2 3 4 5 6, let's see this in this example. Lesser than k you are interested in, and if this k is 24, as in the previous example, this k is 24. So what all the values are lesser than k up to this? So mark them favorable now guys, mark them favorable, and all the values for greater than k, mark them unfavorable. As simple as that. Now Start your binary search. Yeah, what are you waiting for? Start your binary search. Pause this video. What you want? The index of last element in the first space. And if you know, if you're coming from part 2 video, you know this drill, that where h, like l and h will give your answer, and where at end of loop at termination, where your l and h will be, h will be here. Why? Because h started, if h is like h is at the second space, and so during termination, like at the end, h will point to the last element of first space, and l will point to the first element of last space or second space, whatever you want say. So who gives your answer? Do you want this index, the final index of first space? Who gives your answer? H gives your answer. As simple as that. H gives your answer. That's it, guys. So what you have to do to write this algorithm, to write this thing, let's say you got your L and H, this pointers L and H, like from where you have to search. Start searching. Mid is equals to L plus, I hope like I don't have to write all these things again and again, but just for this sake, I'm writing it, no problem. If what was that? A of mid is less, and what was the favorable space? Favorable space was K, lesser than K. I mean, if it is lesser than K, you have to, and you know, if it is, let's say, you wanted what? The last favorable. So if it is, if you're landing at some favorable, you have to go to right, guys. You cannot go to left. You remember this? You cannot go to left. Why? Because your answer lies in right space, right space. So what you want to do, you have to do L is equals to mid plus 1. And the other thing is else condition, it is unfavorable, greater than equal to, you have to keep h is equals to mid minus 1. That's it. And who returns your answer when this loop is ended? Return h, sorry, return, what is this, L, I think. No, return h, I mean, yep, return h here. So what you have to do, return h directly. Okay, return h here. So if you guys see this carefully, so here if you see, why the first thing is, I'll quickly erase this space, create some thing to write. So if you guys saw this carefully, so what is our thing? The first step is to short the array space, array space. Second, start the two loops, for and for. This is I and this is j. Now this I and j, this I will give you a side, this j will give you b side. Okay, and then what you have to do, from j plus 1 till final index, call a function that will return you, let's say this index, it will return idx. And what it will return, you know, if a is 4, b is 20, so a plus b 24, and it will return the final, like in its right, which is the index, final index, which is like lesser than 24. So it is obviously fourth index, so you get this idx as 4. So this function you saw, we write, like we wrote this function here. Okay, so let's call this fun. We wrote this function here, no problem. So what we got till now, we got this idx. Now let's say you keep a counter variable, sorry, some variable ans, or let's keep it ans, and this will like tell you how many triangles till we have formed, like how many triangles we can form. So with these two a and b, so with this two a and b sides, let's keep ans plus equals to whatever your ans was. You'll be adding how much more triangles to it, this whatever this index you got, 4 minus index of this j, so which is idx minus j. That's it. So this is what all your possible, like idx minus j, 4 minus 1 3. So with these two sides, how many triangles you can form? Total of 3 triangles you can form, keeping c as this side, or this side. Okay, so I hope you got the idea for it, guys. And in that way, for every two like pairs, for every ij, you have to do like go like this. Awesome. So here you see my solution. I you can like pause the video earlier, sorry for that. So this was a fun. You see, we return what? We return h. This is our favorable. I earlier wrote an if, here I wrote an else, no problem, because you can see there is no change. Okay, so this is what, and you will return h. What we return here, we also return h, no problem. Okay, this is your function. As I said, keep an ans variable. First step was to short it, then we'll obviously go for two loops, for and for. You calculated the index, And what is LNH? L will be j plus 1 index, because what you did, you wanted for 4 and 20 as A and B sides, the C side should be at least not in this range, because these are two already occupied. So C side would be greater than this j plus 1 index. From j plus 1 index till the last index you have to find. And what k is this? Nums of I plus nums of j, A plus B, that's it. You got idx. Now uh, you like what we did here, we find how many triangles are they, like how many are they. So j was here, if j was at 1 index, k you found at 4, so 4 minus 1, 4 minus 1, which is 3. So three triangles we can form. So what you did, ans plus equals to 3. So you added 3 to your ns variable, ans variable, sorry. So I hope you guys got this, that how we like wrote every step. From, in fact, from linear search we went to binary search. It's not like we directly jumped to binary. We saw that in order of n cube solution you can go for every possible triplet. And then we decided, like, we can obviously divide this when we saw that we have to find the largest value like this, and we know that we can divide this in search space, two search spaces, and that is where we got the hint for binary search. I hope this thing is clear, guys. If it is not, do let me know in comments. I'll help you somehow. Hi everyone.